friends. I hope all of you are fine and doing well. So topic we will discuss today it is the compounds of silicon. As we have already learned, the silicon is mainly from the group 4A elements and it has 4 electrons in its valence shell. The main property it is the tetravalent. It means it can combine with 4 other atoms of an element and it make the mainly covalent bond in nature. So this is a simple overview about the silicon. Silicon can make a wide variety of compounds. The first one is silicon can combine with one oxygen atom. Silicon can combine with two oxygen atoms. Then two silicon atoms can combine with one oxygen atom. And that we have two silicon and two oxygen atoms. Then we have two silicon and three oxygen atoms. Then we have two silicon and here we have three oxygen atoms. So here this is the transverse in the structure of the silicon dye, how it is going to be bond and forming the stable structures. Here we have two silicon and four oxygen atoms. So silicon can make the oxides by combining with the oxygen. It can make the halides by combining with the hydrogen, and it can make also the different hydrides combining with the halogens and hydrides by combining with the hydrogen. So this is the simple compounds of the hydrogen, how it can combine with the other different elements to make the stable compounds. So let's have a look on the oxides of the silicon. First one we have silicon dioxide, in which one silicon can combine with the two oxygen atoms, making a dioxide means two oxygen atoms. Its formula we have SiO2. As the silicon, here we have its dioxide form, so two dioxides can combine with this one another and making the long chains or the branch-like structure, as this branch-like structure is mainly known as the silicon dioxide. So it is mainly known as the general name which is called as silica. It is probably most common or we can say that the most important compound of the silicon. In the silica, here we can see that every silicon atom is tetrahedrally attached. So if I'm going to show here the tetrahedral structure, you can see that this. So every silicon atom is having a tetrahedral structure that's combining it with the four oxygen atoms, oxygen number 1, 2, 3, and the oxygen number 4. And two of the oxygens are close and the two are far apart from each other. So this is the simple structure of the silicon dioxide and it is mainly the crystalline structure of the silicon dioxide. But when this crystalline silica is just heated up to the limit, it started to melt and after melting it forms a structure that is viscous in nature or we can call it viscous liquid. It is having now the random structure or irregular structure and in which the silicon atoms are still having the average close to the other oxygen atoms. Again, when this heated silica is allowed to cool, it does not changes into the silicon dioxide that was crystalline in nature. So in this which started to heat, then melting to then again cooling will not make the original reactant. So this is the simple silicon dioxide. After that we have the quartz or this is also known as the quartz glass. Mainly quartz glass it is consisting of silicon along with the two oxygen atoms. It is mainly the crystalline form of the silicon dioxide. What are the properties of the quartz? It is mainly hard, It is refractor, it is mainly colorless, and it is present in the solid state. So it makes it different from the oxide of the carbon, and the oxide of the carbon was carbon dioxide. It was in gaseous state, but it is hard and in the solid state. On the other hand, the quartz is highly brittle. Now, brittleness is it's one layer just slipped over the other layer. Here we have silicon dioxide, its electronic structure, that how many electrons have been shared. On the other hand, here you can see that every silicon is tetrahedrally bonded and making the bonds with the oxygen atom. So this is the simple crystalline structure of the quartz that is different from the carbon dioxide. After that, we have the properties of the vitreous silica. Now, the vitreous silica, this topic is new to you, that what is mean by this. Mainly, vitreous silica is just possesses some interesting properties. The number one we have, it is having high transparency of light, transparent. It is very refractory in nature. It can refract the light, and it is having low thermal expansion. Low thermal started to expand at low heat. It is used as insulator. Now, you guys must know what does mean by vitreous silica. When they heat the quartz glass, it started to melt and it changes into the silica glass. That process is known as quenching. And as a result of melting of the quartz, we gain the type of silica which is known as vitreous silica. Here we have silicon and oxygen atoms. So this structure we have, it is in irregular manner. It is having no regular structure or not a 3D structure, as it is we can call as the random structure or the random arrangement of the elements. This is known as the vitreous silica. When the temperature is 300 Kelvin and it reaches almost 3,000 Kelvin, then by cooling again to 300 Kelvin, we gain the silica glass, not the quartz glass. So melting and then the quenching. So this is the process of the formation of the vitreous silica. On the other hand, this property, it is a having high transparency of light, refractor, low thermal expansion, insulator. It is also hard in nature. It is insoluble in water, and it is also resistant towards the acids. Just it can react with one acid, that is HF, hydrofluoric acid. So this was a simple compounds of the silicon from the group 4, remember. I hope you guys understand, and if you have any queries you may ask me about that in the comment section. And the next topic we will discuss about the silicates and their types. These are also the compounds of the silicon. That time you guys keep learning and have a good day.